Hello and welcome back. So here we are, continuing with the terrain mesh.
All right, now we're going to work on update. Now, several videos back, I said that update is how we're going to assign a mesh to a new location because we're going to be reusing these meshes. I don't want to, create one and just throw it away to turn around and have to create another one with pretty much all the same information and then force that poor garbage collector to clean up after my mess. Because I've found through a lot of experimentation, if you do that, it will come back to haunt you. So what we're going to do is we're going to reuse these meshes. To do that, we're going to have our update take in a vector 3 to hold the new position of our mesh. So along with copying all the information into the mesh and resetting it, we're also going to assign that the position for the mesh. So the very first thing we're going to do is take position with a capital P, which is our property, and we're going to assign it to position. Now, if you remember the property just simply takes the mesh object's transform and assigns its position based on whatever we set it to. So that's all we're doing here. Next thing we're going to do is we're going to take our mesh object. We're going to set its name equal to terrain patch colon brackets and then squiggly 0 comma squiggly 1 and then let's go ahead, hit Alt Enter, put a string format in place. We'll send in position dot x comma position dot y, or sorry, z, and I'll put a semicolon at the end, and I forgot a parenthesis, so that'll clean that up. Now, after that, I'm going to take our mesh. I'm going to clear our mesh. Oh, wrong mesh. Don't clear that mesh. Probably bad things would happen if you tried to do that. So we're going to take our mesh, we're going to clear it. Now, every time you set a mesh, you need to clear it. So you can't just assign new values inside of the old values. It doesn't work. So you clear the mesh and then you assign all the new arrays to their counterparts. So now that we've cleared the mesh, I'm going to set the mesh's name. So I'm going to set its name, and I'm going to set it to exactly what I named the mesh object. So not a real big use in the regular editor in this part of it, but when it comes to the exporter, this helps with keeping track of stuff, assigning the mesh name, because when we end up baking out the prefab, a lot of it's going to be assigned based off of the mesh name, and we'll see that later on. So, all right. It also helps when figuring out whether or not we've assigned the collider correctly, because otherwise it just says mesh. All right, mesh vertices. So we're going to take mesh dot vertices, set that equal to vertices. Take mesh dot UV, set it equal to our UVs. Mesh dot triangles, and set that equal to triangles. And we're going to take our normals, so mesh dot normals equals normals. Now, right now, these have nothing, but I'm not worried about it. I'm just going to put them in place for now. We'll do mesh dot, oops, wrong one again. Tangents equals to tangents. And then mesh dot, wow, You figured to get the hint. So mesh colors equals colors. All right. From here, I'm going to do a mesh dot recalculate bounds. And until I get the other code in place for calculating out tangents and normals, I'm just going to go ahead and do the mesh dot recalculate normals. So that will take care of that. And we can go perfect. I might have to comment out tangents. I'll check afterwards. All right. That will take care of assigning everything we need with the exception of the collider. Now, the reason I waited until now to assign the collider is the fact that the collider is where we're going to incur that penalty. So you want to wait until the last possible moment to create the collider. In some of my experiments, and if you guys don't have the Pro version, you'll want to set up lazy collider construction. So one of the things that I've done, but I took out of this version of the editor because it's not needed for us in this particular one, is that I set up the mesh to not create the collider until it's told to. So I have another method that is called add collider, and then it gets called when the train manager, another class that you haven't seen yet, tells it that it's time to add a collider. Basically, I just do a distance check on a train patch or train mesh and see how far it is from the character. Once it hits a certain range of the character, it fires off that add collider, and it's at that point and only that point that the collider for those meshes that are within range of the player get added, as opposed to creating a collider for every single mesh. Now, like I said, if you don't have the Pro feature and you're going to be using this system as your main train system, and you would like to go with some larger patch sizes, or you just want to get a little bit more optimization, I definitely recommend doing that technique as opposed to what we're doing now, which is going to cause the mesh collider to be created on every single mesh the moment that it is constructed for the first time or updated every time we update. Now, the reason I'm doing this and I've taken out that lazy construction is because we are building this as an editor, not so much as an editor and a game engine. What that means is basically we're planning on sculpting on everything in the game that you can see. And the only way we can sculpt on the stuff in the scene that that's visible is if it has a collider, because our array casting will not intersect the terrain when we're trying to sculpt if that terrain doesn't have a collider. So every patch has to have a collider, which is why I got rid of it in this case. But if you're not doing what we're doing, then definitely look at putting in a lazy system for creating the mesh collider only when it's needed. So we're going to set share. So we're basically now checking and say if the mesh collider doesn't exist, or it does exist, sorry, my bad. If it's not null, if it's already been created, we're going to set the mesh collider shared mesh, not material, equal to null. We have to null out the existing collider before you can assign another one. If you don't do this, it won't work. So we'll hit mesh collider. Wow, seriously?
The big famous Lee sigh. Oh, seriously.
Oh, it's not as epic as Nelson's, though. I'm
This is
still
true.
working on it. So we'll set the shared. You had to do that.
I wasn't going to say anything.
All right, so we're going to set the mesh collider shared mesh to be equal to our mesh.
Mm-hmm.
Now, if the collider doesn't exist, we're going to assign it now. So mesh collider equals mesh object dot add component, and I'm going to add the mesh collider to it. Now there's a couple of cool things that I found out while trying to optimize this as much as possible. When you type in add component mesh collider, you do not have to then go in and set up shared mesh the very first time. When you add this component, it's going to look at the mesh filter, and if the mesh filter has information in it, like here with these vertices and triangles, it's going to use this information to create the mesh that it adds to the shared mesh of the mesh collider. It does it for you the very first time. This is why I delayed adding this command until this point in time, as opposed to creating it up here. Because if I created it up here, we would have hit one performance hit while we were trying to build this information. Then we would have updated the information, and we would hit another performance hit when we did the update. So I'm just reducing that performance hit for adjusting the collider to a single hit as opposed to a double hit.
Right.
So, and it just makes the code a little bit cleaner this way, as opposed to going, hey, add component, null this out, add the mesh to it, and now we're getting multiple construction or mesh collider construction hits. So not so bad when you only have 81 vertices. Bit different when you've got 45,000 of them.
Right.
But I'm just saying. So that is going to be our update. So if we go over to our train demo now, where we've done this new train mesh, and we do var mesh equals new train mesh, and then we say mesh dot update position. Let's give it say vector 3 dot 0. That'll create us a mesh at the origin, hopefully, if everything works. So let's push the button, see what happens. So hey, look, it's a train mesh.
Awesome. Hey, what do you know? It even looks the way you drew it in Photoshop.
Wow, even better.
But
and
you could
no
now
reverse
demonstrate
ones.
changing your step size.
Yes, I could. What, you don't believe that it really works the way I said it does?
No, I'm not saying that at all.
Well, I just trust it. It's like a shh, don't say anything. Okay, so let's change our step size to 4. So I've changed nothing else. I haven't changed the vertex count. I haven't changed the spacing. The only thing I've done is change the step size. So if I hit play.
Very nice.
So, and just to prove that it does work, if I hit 8.
For the big square?
Yeah, for the big square.
Very nice. Very nice.
So. And if we look at stats, we can see we've got 92 triangles and 265 vertices, which shouldn't really be possible with one object in the whole thing. So that's interesting. I know the vertices are going to be high. I'm not quite sure why the triangles are so high. So something else is in my scene. Now, what is it? Okay, hold on a sec. Mesh render, turn off. So there are still 84 triangles. Okay, now what's in my scene? That's impressive. Hold on. Wow. Okay, have you ever wondered how bad a GUI text can be? Look at that.
Yep. Look at all those draw calls. That's just one. Again, look at all those draw calls.
But it's using 84 triangles to draw just the text.
Right.
But now I've got 12 triangles and 24 verts.
Yeah, what about your skybox?
Yeah, the skybox is in there. I know that, but it should be, if it was counting those vertices and triangles, it should be more than that. Because each face would be 2, and there's 6. Well, no, that would be 12, wouldn't it? Yeah, what do you know? Okay,
Yep.
cool. So hold on. I gotta stop this because I want to see an accurate number. So if I take this, we turn that off. We take our camera, we turn off skybox, and we'll go solid color. One draw call, 8 triangles, 81 vertices. Notice, we've got 8 triangles, but if you look at just this, it's going, well, hold on a sec, I've only got 9 vertices. No, we still have all 81 of the vertices. We've just skipped over a whole bunch of them just to draw a lower res triangle mesh.
Right.
The vertices are still there. We haven't gotten rid of them, which was one. This is what bit me when I was trying to optimize the LOD, because I could do this quite easily, but then going back to reduce the vertex count,
Mm-hmm.
I was removing them. So I had an additional step that was removing all the vertices that weren't being used, and that caused a whole lot of extra processing, and it just wasn't efficient.
Gotcha.
So especially when you're doing it every frame and you've got 400 of these little suckers around,
Right.
and you're trying to update those and adjust their colliders all at the same time, just wasn't going to have it.
Right.
I think if it wasn't for the mesh collider, the fact that we can't optimize the construction of the mesh collider or have more control over it, we could probably pull it off.
Mm-hmm.
So, but I just wanted to show that, as you pointed out, yes, step size does indeed work, and
Mm-hmm.
it affects it. So, not that we're actually using it, which is why it's hard coded to 2
But
right
it was
now.
still cool to show them
Yep.
and demonstrate it. Yes.
Yep. And if they want to use it, they can. And
Mm-hmm.
basically, the way I controlled it when I was using it, I created an LOD property that was based off an enumeration, and that enumeration had my step sizes. So I had a LOD 0, 1, 2, and 3, and they were just hard set to which step size to use. So LOD 0 had a step size of 2, LOD 1 had 4, 3 was 8, and no, hold on, was it 0, 1, 2 was 8, and 3 was 16. So, and then it would just switch the LOD level, and it would reprogram the create triangles. And then what I had was inside of update, before everything else, was a program that would recreate the triangles, and then another method that would simplify the vertex. And it would go through and it would recalculate all of these just using the vertices that were still active based off of the triangle. So I would iterate through the triangle list, pull out just the vertices, and rebuild all of them based off of that information. Just little hints in case you do want to mess with it.
Very cool.
So, and let's do one other thing
Okay.
that we can. So just for fun, just because we can. And this will be z, oh, hold on, x comma 0 comma z. All right, that should work. Let's see what happens. So that did not work. Why not? Oh, I know why. Because I also have to modify the spacing part. which I do in the train patch, but to make this example work, I'll have to do it from here. So this will be position times spacing. Is it spacing? So position times size times spacing.
Position times size times spacing?
Yeah,
Okay.
I think so. If not, I'll change the equation. Oh, almost. No, now what am I missing? So I'm off by, oh, size, yeah, okay. Get the rest of the equation right. Here. So size -1. Forget about the extra vertice. So we take that, multiply that by that. So that gives us that. And then I need to go here and make this less than or equal to. There we go. That should do it. If not, I'll change it. There we go.
Cool.
So now we've got a 3x3 grid. And it works.
Very nice.
So
does that pretty much wrap up all the videos for the terrain mesh?
well, for the TerrainMesh, yes.
Yeah. So what are we moving on to next?
Bed? No. No, the next thing that we're going to be looking at is probably starting with the train patch. We're going to put some basic parts of the train patch in place to get us working. And in conjunction with the train patch, we're going to be looking at the object pool, which I call my object pool, kind of similar to my thread pool, just to keep the naming similar. But we'll start looking at creating an object pool as well. And, well, now that I think about it, let's do the object pool next before I do the patch. Okay. That way we can explain the object pool, how it works, demonstrate all that. Then once we've got that code in place, we can then use it to work in conjunction with our train patch. And then we'll implement the basic part of the train patch. We will have to revisit it once we get the vertex cache in place. But I want to get the patch part started before we start looking at the vertex and vertex cache classes.
Okay.
So we've got quite a bit of work ahead of us still.
Awesome. So. All right. Well, is that going to be it for this video then?
Yeah.
All right.
That should do it for this one.
Looking good. All right, guys. Thanks a lot, and we will see you in the next video.